Hello everyone, welcome to the 6th video lecture of class 9 science. We are dealing with the first unit, measurement. In this video lecture, we are going to learn about mass and weight, measuring the mass using beam balance, physical balance, spring balance and digital balance. So first we'll be looking into what is mass. So mass is the amount of matter present in a body or an object. Mass depends on number and type of atoms present in an object. Mass of an object will be constant regardless of where the object is. So what it exactly says? So mass is the amount of substance present in an object. How much matter or how much substance is present in an object, that will be called as mass of that object. Okay, so this mass of an object will be depending upon the nature, what type of an atom is present inside that object. So mass exactly depends upon that. And then mass is such a quantity which will not be depending upon the place where the object is. So now I have an object. So we are on earth. So mass of an object on earth is 10 kg. If I am taking it to the moon, the mass will be still 10 kgs. It will not be reduced or it will not be increased. So that is what it says. Wherever you are, wherever the object is, the mass of the object will not change. That means the amount of substance present in that object will not change wherever you go. So it's like you're at one place, you're traveling from your place to Chennai. That means, so will your mass change? Will there be any loss in your mass? No. Will there be any increase in your mass? No. So wherever you go, the mass of an object or mass of a body will not change. Okay. Then the SI unit of mass is kilogram. We know that mass is a base quantity, that is fundamental quantity, right? Its SI unit is kilogram, kg. Okay, this was about mass and we are quite familiar with the concept of mass. Okay. Next, going on to the similar concept, that is weight. So we have learned about, we just heard what exactly the mass is. Now we are talking about something called weight. They are a bit similar. See, in day-to-day life, we generally use the word weight for mass, right? So we say, what's your weight? We just say 50 kgs or 40 kgs, right? So the 40 kg or the 50 kg is not the weight, that is mass. So in day-to-day life, we actually wrongly use the word weight instead of using mass. So what exactly this weight is? How it is different from the mass? So weight is the measure of gravitational attraction or pull of an object. Okay. So we all know that there is something called gravitational force which is pulling us towards the earth, right? So we are all staying on the surface of earth due to this force. So it's a kind of an attractive force. It is, the earth is attracting all the object towards it, right? So any object which has got mass will be pulled or will be attracted towards the earth, right? That is what we know. Okay, so how much, it's a force, the attractive force. How much force an earth will be applying, with what force the earth will be pulling an object, will be the weight of that object. I hope you're understanding. With what force the earth will be pulling or attracting an object will be called as weight of that object. Okay. So it is calculated as weight is equal to m into g, mg. Okay, where m is the mass of the object, and g is the acceleration due to gravity. Since we are talking about the Earth's surface, so the value of g on Earth's surface is equal to 9.8 meter per second square. Okay, 9.8 meter per second square is the value of g on the surface of Earth. So if you go to some other place like moon, the value of g will change. I hope you are understanding. G is constant on the surface of Earth. If you go to moon, the value of g will change. If you go to Mars, the value of g will change again. Okay, so this g is constant on surface of Earth for now. You just take it in your mind that g is a value which is constant on Earth, which is equal to 9.8 meter per second square. Okay, so we said that weight is an attractive force with which the Earth is pulling an object towards it, right? So it is kind of a force. We know that the SI unit to force is nothing but Newton. So for this force also the SI unit will be Newton. For any kind of force, the SI unit will be Newton. Okay. So here there is a difference between the big difference between mass and weight. Value of weight depends on where the object is, where the object is present. So as I said, weight is calculated as product of mass and gravitation, acceleration due to gravity, that is m and g. We know that g value will not change on the surface of Earth, but it will change as we move from Earth to moon or Earth to Mars. On different bodies, its value will be different. So now mass will not change. I'm having 10 kgs of mass, and its weight on Earth will be 10 into 9.8, and I'm traveling to moon with that object. The mass of that object is again 10 kgs, but the value of g will change. That means the value of weight will be changing. That is what we say, the value of weight depends on where the object is. So the place where it is matters to determine the weight of an object. Okay. So the pull of gravity, so I said it will be different, right? I said on moon the value of g will be different, hence the weight will be differing. So how much it is? The pull of gravity on the moon is 1/6 times weaker than that of the Earth. Okay, 1/6 times weaker. That means less. Okay, if on Earth, if it is 6, okay, something like 6 newtons, then on moon it will be 1 newton. 1/6 times means divided by 6. Okay, this causes the weight of an object on the moon to be less than that on the Earth by 6 times. So I said if the weight on Earth's surface is 6 newtons, on the moon's surface the same object will be equal to 1 newton, less by 6 times, right? Or on Earth it is 6 times more. It is 6 newtons, the other one is 1 newton. So it is 6 times more on Earth. Because why this is happening? It is because the acceleration due to gravity on moon, that is g, is equal to 1.63, which is 6 times lesser than that of the acceleration due to gravity on the surface of Earth. So 1.63 meter per second square is the acceleration due to gravity on the surface of moon. On the surface of Earth, the value of acceleration due to gravity is 9.8 meter per second square. Okay, So we are taking one small example. Mass of an object is 10 kg. Now we are measuring its weight on the earth's surface, that is equal to mg, which is equal to 10 into 9.8, which will give us the value as 98 newtons. Weight of the object, which was 10 kg mass, is equal to 98 newtons on the surface of earth. Now the same object is weighed, calculated its weight on the surface of moon. So here mass value will be 10 kgs. Okay, 10 into 1.63, because the g value on the surface of moon is 1.63, no more 9.8. Okay, therefore 10 into 1.63 will give you 16.3 newtons. So if you see, the weight on earth is 6 times more than the weight on moon. The object is same. Okay, mass is same, but the weight is different at different places. Okay, this was a major difference between the mass and the weight, and this has got very much misconceptions. Like, we normally use weight instead of using mass. That's the biggest misconception, right? But for general purpose it's okay, but you should know that what we're actually talking about is the mass, not the weight. Weight is kind of a force which is pulling us towards the earth. Okay, a gravitational pull on an object is called as the weight. Okay, so weight is nothing but a sensation. Gravity keeps trying to pull us towards the earth, and we get pressed against things. So whenever we stand on a weighing machine, what actually we does, when we stand, we feel that we are pushing that object down, right? We are pushing that scale down. Okay, that pushing is happening because the earth is pulling us towards its center, right? Yes or no? So that's why we say that, we feel that we are pressing the things which is below us. So hence we feel that there is some weight. Okay, weight is just a sensation, it is just a force, but mass is the amount of substance present in an object or a body. Okay, so this was about mass and weight. So what are the differences between mass and weight? So mass, as we know, it's a fundamental quantity, a basic quantity. But weight, it's a kind of force. Force is a derived quantity. So weight is also a derived quantity. Mass has got the magnitude, right? We can say in terms of numbers, like 10 kg mass, 12 kgs of mass. We can say that. Magnitude means numeric value given to the physical quantity. So it has got magnitude. Okay. Does it have any direction? So it's like, if I'm seeing the mass, one particular object is present, its mass will be 10 kgs if I see from left. If I see from up, its mass will be 12 kgs. Will it happen? No. So all the directions will be same. That means, like, it's just a relative thing, not exactly what the direction mean. Okay, so mass just has got magnitude, it does not have any direction. Okay, so it is called as a scalar quantity. A quantity which is having only the magnitude will be called as scalar quantity. Here the mass is having only the magnitude, it do not have any um, direction. That's why it is called as scalar quantity. Okay, coming to weight, it has magnitude. Yes, of course. We even saw how to calculate the magnitude of the weight as m into g. We even calculated for the case of 10 kg mass as 98 newtons on the surface of earth. 16.3 on the surface of moon. That means it has got the magnitude. Okay, then about the direction. So we know that we are pushed, or we are pulled by the earth's surface or the moon surface, or if you're on the Mars, it will be on the moon will be pulling you towards its center. So pull, that means it is downwards, or some, that means downwards we say, right? So that itself will say that this has got the direction, right? So the weight is in the direction, in the downward direction. Okay, I'm feeling it in the downward direction. Okay, so that itself will say that weight has got a direction. So that means weight is a quantity which has got both direction and the magnitude. So that's why it is called as a vector quantity. If it is only magnitude, it will be called as scalar quantity. If it has both magnitude and the direction, then it will be called as a vector quantity. Okay. So how exactly the mass is defined? It is the amount of matter contained in a body. Amount of matter present in a body is called as mass. Okay, quite simple. So in the case of weight, it is not the amount of matter present in a body, it is the force, normal force exerted by the surface of the object against the gravitational pull, right? Okay, so it is just a gravitational pull on an object. Okay, then moving on to the fourth one. The mass remains the same everywhere, but the weight varies from place to place. Okay, this we have discussed in detail. Mass is measured using physical balance. Weight is measured using spring balance. More about this we will be seeing in the next, uh, I mean, in the coming classes. Then, for now, you just read it as mass is measured using physical balance and weight is measured using spring balance. That's it. More about it we will discuss further. Okay, the SI unit or the unit of mass is kilogram, whereas unit of weight is Newton. So these are the 6 major differences between mass and weight. I hope by now you're a bit clear about what is exactly mass and what is exactly the weight. Okay, now moving on. Measuring the mass. So we all know that the SI unit of mass is kg. The units are based on the items we purchase. SI unit is kg, but always we are not measuring the mass in terms of SI unit only. We use other units also in our day-to-day life. So it will be based upon the use, the item we purchase. So whenever we go for purchasing the gold, we purchase in terms of grams and milligrams, and if you're so rich you go for buying the gold in terms of kgs. Okay, just a random thing. Okay, the next thing is medicines, we take in terms of milligrams. Mg, you will be seeing it in tablets, right? So it will be so much of mgs and all something. So milligrams, and then provisions like your sugar, jaggery, dal, and then yeah, those kind of provision items which you will be buying in terms of grams and kilograms, like 1 kg of sugar or half a kilo of sugar. That is nothing but 500 grams of sugar and all, like mustard, sesame, all those things. Provisions you buy in, when you're going to buy the provisions, you will be expressing the mass in terms of kgs or grams. Okay, then you go for cargoes, then you will be expressing the mass in terms of tons. A big cargoes, right, a huge ones, you cannot talk about in terms of kgs. It will be a very big number. If you go on talking in terms of kgs or grams, it will be a very big number. So we talk about in terms of tons. Okay, so what exactly we are trying to say here is The units which we use for expressing the mass will depend upon the item we are purchasing or the item which we are talking about. Okay, it will not be always kg. It is the SI unit, but always when in our day to day life we go for other units also. It is same for all physical quantities. Like we go for, in case of length, we go for centimeter measurement, meter measurement, millimeter measurement, and the kilometer measurements, etc. And even the light year. Yes, we talked about all those things, light year and everything. So we go for different units, but a standard unit is also there. For length it is meter, for mass it is kg. Okay, so since we have different units, so can we use the same instrument for measuring all the above listed items? So for gold also I can use the same instrument, and for the huge cargoes also can I use the same instrument? No, absolutely no, right? So for that case, we have different measuring instruments or devices are designed so that they are used depending upon our need, or depending upon the purpose for which it is used, right? So some of such instruments are beam balance, physical balance, digital balance, and the spring balance. So we are going to see one by one what are they, up to what mass they can uh, measure, and all those things in detail we are going to see one by one. The first one is beam balance. So you're quite familiar about this beam balance, right? Common balance it is. It's called as common balance. So you have seen this one also in market and all. Sometimes they use this. A beam balance compares the sample mass with a standard reference mass. So we all know that there will be some stones kind of a thing. They are nothing, where the standard things are written like 5 gram, 10 gram, 20 grams, 50 gram, 100 gram. All those stones, it will be written with 200 grams, or 1 kg stone will be there. So those stones will be kept on one side of this balance, and on the other side we put what we actually want, like tomatoes, or potatoes, or sugar, all those things, right? What we want to buy. So actually what we are doing, we are comparing the sample mass. Sample mass are nothing but what we are actually purchasing, like your sugar, jaggery, or whatever. That we are keeping on one side. On the other side, we are keeping the standard reference masses. Standard reference masses are nothing but those stones on which it will be written as 1 kg stone, or 2 kg stone, or 200 gram stone, 500 gram stone, 250 gram stone. All those things will be written. So okay, so it is beam balance just compares the standard mass with the sample mass. This balance can measure the mass accurately up to 5 kgs. Okay, usually the beam balance are used to measure the masses up to 5 kgs. Usually we know there are many beam balances, which common balances, which even measure the mass more beyond 5 kgs, but generally it is up to 5 kgs. Okay, then the next one is physical balance. So you might have seen it, but nowadays these are very rare. Before they were usually used in jewelry shops and all, and yeah, it will be kept inside a glass box. It will have two doors, and inside that glass box you can see the exact picture of common balance, but a miniature one, like smaller beam balance or the common balance will be seen inside this glass box. As you can see in the picture also, there are two plates hung similar to that common balance. Okay, so this balance is used in labs. Okay, it is very sensitive one. It is similar to the beam balance, but it is lot more sensitive even to the air. That's why it is kept inside the glass box. Can measure the mass of an object correct to a milligram. So with a common balance, we could measure from 5 grams, 2 gram, 5 grams, 10 grams, 20 grams, up to 5 kgs. We were not able to measure in the milligram weight. Sorry, not the weight. Sorry, again, I should not be telling. We even measured milligram amount of mass, but we could not measure milligram. But using the physical balance, we can measure the smallest masses whose mass is in terms of milligrams. Okay, the standard reference here also, what exactly we are doing is nothing but comparing the standard mass with the sample mass. So plate, we will be on one plate, we will be keeping the standard mass. Here the standard masses will be 10 milligram, 20 milligram, 50 milligram, 100 milligram, 500 milligram, 1 gram, 2 gram, 5 gram, 10 gram, up to 200 gram. So these are the standard masses, kind of a stone, or it will be like small plates, tiny plates. Okay, pallets, kind of things. Okay, they will be used as standard masses, and the sample mass will be kept on the other side, and we will try to compare or balance the things, and we say that it is of this much mass, it has this much mass. Okay, this is how the physical balances are used. So going to the next one, digital balance. This one I am sure all of you might have seen in your everyday life. Nowadays these balances are common. Nowadays, for accurate measurement, digital balances are used. Okay, so they give most accurate measurements, which measure mass accurately even up to few milligrams, the least value being 10 milligrams. Up to 10 milligram, the lowest of 10 milligram, we can measure using this digital balance. The electrical device, it's an electrical device because it requires electricity. Electrical device is easy to handle. We need not keep it like we kept what the physical balance inside a glass one, and there should not be any air blowing over there. If there is any air, then it will try to swing. I mean, those plates which are hung actually will start to swing. All those problems will not be there. Much of those problems will not be there in the case of digital balance. It is very easy to handle. Nowadays digital balances are of different calibrations are available. Like you can even use a huge digital balances also, which can even measure the tons and so much things, right? So from starting from 10 milligram, you can measure up to tons. So such kind of digital balances also are available in today's world. So this is a modernized version of balance, I must say. So this was about weighing different balances. The next one is the spring balance. So as the name says, spring balance, that means there must be a spring, right? Otherwise who will give the name spring balance to it, right? So there will be a spring in it. So using that spring, using this principle behind the spring, we are able to measure actually the weight. Here actually we measure the weight of an object. Then if we want, we can calculate its mass. So you can see in the picture also, the balance helps us to find the weight of an object. It consists of a spring fixed at one end and a hook attached to a rod at the other end. You can see there is a hook here, right? Hook kind of a thing. Yeah, hook kind of a thing is present, and one side, this is the spring in middle. You can see here is the spring inside it. Here the spring is present. So inside this device there is a spring. One end of the spring is attached to a hook here. Okay, another end is fixed to this fixed end. Here it is fixed. Another end is open, which is given to a hook. It works by Hooke's law. So the principle behind the spring balance is Hooke's law, which states that the addition of weight produces a proportional increase in the length of the spring. So we all have seen this, right? Whenever we give more force to one end of the spring, it will try to expand. So that is what we are doing. So we are keeping, or we are putting some objects into this hook. So what happens? It will try to pull the spring downwards. So because of which there will be an extension, elongation created. So that will be measured using a pointer. You can see there is a pointer, an arrow mark thing over here, a pointer, which actually shows when it expands, when the spring comes down, this pointer also will move down along with the spring. So that will say how much elongation has happened, and that elongation is equal to, that is proportional to, not equal, it is proportional to the weight of the object which is hung here. Okay, how much weight you are hanging here, that much of extension will be happening in the spring. If you are keeping a small weight object, the extension will be small, the elongation of the spring will be small. If the weight of the object is more, the elongation will be more, therefore the pointer will come larger distance towards downside. So that is how the hook or the spring balance works under the principle of Hooke's law. A pointer is attached to the rod which slides over a graduated scale. You can see there is a scale which is written 0, 10, 20, 30, 40, 50 on the right. The spring extends according to the weight attached to the hook, and the pointer reads the weight of an object on the scale. So that is what we said. When you put some weight on this, when you put some weight on this, in this hook, so what happens, the spring will expand. Along with the spring, the pointer will come down and it will start to show some reading on the scale. So that is nothing but the weight of that object. So where the pointer is marking, that value will be equal to the weight of that object. So this is how the spring balance works. So once we know the weight, we can even calculate the mass. Okay, so this was about all 4 different kinds of balances which we have to study, and previously we even studied about mass and weight and their differences. So that's why in the difference column, when we saw, it was written physical balance or the common balance are used to measure mass, and in the case of weight, spring balance is used. So this is how it is used to measure the weight. So this was about today's lecture. So we are one more class, we'll be finishing off this chapter. So please go through the textbook thoroughly, this lesson thoroughly, and try to do your exercise also, which is given at the end of this lesson. Thank you.